Okay, so we're going to be dealing with topic says accumulation function, so talking about what it means when you are finding your integrals. So basically the meaning of a definite integral. Now this is if everything's above the x-axis, so you don't have, not dealing with like negatives, okay? So from a to b of f of t, so that's just whatever your function is. Down here the graph in red, that's your f of t function. From a to b, whatever x value to y value they give you, is measured using the product of the units on the x-axis, usually time, and the y-axis. So on this one, it's saying that the y-axis is vehicles per minute, and the x-axis is in minutes. So when you do an antiderivative, we know it's found by calculating the area under the curve. But if you're asked what is the meaning of that, basically all you have to do is, after you find the area under the curve, is multiply the units on the y-axis with the units on the x-axis. So if I have vehicles per minute and times it with minutes, well, it wouldn't be vehicles per minute squared because this minutes is on the bottom of a fraction and this other one isn't, so the minutes would cancel. So we'd be left with just minutes. Vehicles, yes, thank you. Vehicles. So if you found the area under the curve, basically you found the total number of vehicles on whatever interval they were asking about. Okay, so it's saying T represents the accumulation of these units formed by the product of time, A to B. For each situation below, T is measured in minutes. Find the meaning from 0 to 30. So it says F of T measures the rate of vehicles per minute passing through a highway toll booth. Okay, so the function here, going up to F of T, if you found specific y values at different x values, that lets you know how many vehicles went through that toll booth in that per minute. Okay, so the area under the curve is the total number of vehicles that went through that toll booth from, say, 0 to 30 minutes. Okay, that's all that that area under the curve would be representing. And that's probably what this box is. Okay, so on the AP test, they do like to ask you to find the integral and then state the meaning. What does it mean? So when they ask you to state the meaning, don't ever say it represents. You have to be very specific and don't use the word it. So here it's showing specifically you'd write the integral from 0 to 30 f of t dt. So don't use the word it. Put the integral there. Represents the total number of vehicles passing through the toll booth over the 30-minute period. Now, you wouldn't want to say in 30 minutes because then they might say, well, what 30 minutes are you talking about? Even though the graph over here is only showing us 30 minutes. So you could say the 30-minute period right here, but you just wouldn't want to be a general 30-minute period because they could say, what 30-minute period are you talking about? Or you could say specifically from this 0 to 30-minute period. Okay, so the next one, again, the instructions say we want to determine the meaning of the integral from 0 to 30 f of t dt. So it says a boy is fishing and puts his caught fish in a bucket. F of t represents the number of fish that are in the bucket at t minutes. So what do you think the integral from 0 to 30 f of t dt might represent? Okay, good. The total number of fish caught in that time limit, but what should the units be? What would I call my units? Because on this previous one, I could call my units vehicles, because if I did vehicle minute over minutes times by minutes, I get just vehicles. Not per minute. If you do per minute, then you're dividing by the minute, not timesing it. Fish minutes. We could call it fish minutes. Fish caught minutes. Okay? So you times them together. So my units are fish caught minutes. So basically the integral from 0 to 30, f of t dt, tells me the total number of minutes that these fish are sitting in this bucket. So the first fish that was caught at 3 minutes sat in that bucket for 27 minutes. The second fish that was caught at 6 minutes sat in that bucket for 24 minutes. And so basically they're adding the time of all of the fish together. So fish minutes. Yes?
Oh, was it because of
0 to 30 for the minutes that they gave there. So it says the first fish is caught at 3 minutes, so it's in the bucket for 27 minutes. The next fish is caught at 6 minutes, so it's in the bucket for 20 minutes. And so the integral adds those all up together and says that way if I added them all together, it would be 75, which is the total number of minutes the fish were in the bucket, or the fish minutes. Okay, so the accumulation function is defined from a to x. So a is whatever the lower number on your x-axis is, and then x, whatever they ask for the upper limit of f of x, is the function of x and accumulates the area under the function from constant a to some value of x. And we use the variable t. Notice in the function they have f of t dt instead of x to avoid confusion, so you don't have like a whole bunch of x's over here. Okay, so we're just using a different variable. Okay, so let f of t be the function of the integral from 0 to x f of t dt, where f is the function graphed, so this is our f function. F consists of the lines in semicircle, and our goal is to sketch the graph of capital F. So notice they have lowercase f in the integral, capital F. Basically, they could have called this one right here, that lowercase f, they could have called that capital F prime, okay? But a lot of the times they like to put a lowercase letter to represent something that was a derivative and a capital letter to represent its antiderivative. I usually don't like that notation, so I'll usually just put a prime on one and then the other one not. But the AP test does like that notation where they use a lowercase for something that was a derivative and a capital for the antiderivative. Okay, so now if I want, our goal is to sketch f of x, capital F of x. I could sketch it if I knew specific ordered pairs. So that's what we're going to do in like this table. And then notice they're giving me the relationship that f prime, capital F prime of x is the same as lowercase f of x. So now if I wanted to find where the x value is -4, I wanted to find f of x. Basically, I would be replacing this with a -4. So I'd have f of -4 equals the integral from 0 to -4 of f of t dt. So I know that this right here gives me the area under the curve from 0 to -4. But usually we like it to be from -4 to 0, lower to upper. So basically, whatever answer I normally would have got if I went from -4 to 0, I have to switch the sign. Now I can find the integral by finding the area under the curve, which we did an assignment like this 2 times ago. So I'm going to go ahead and calculate the area under the curve from -4 to -2.5. So when I calculate this area, that's just a triangle. So I can just do 1/2 times the base. My base is 1.5 times the height, and that height is 2. So it's 1.5, but I will call it negative, yes, below the x-axis. Now when I calculate the area between -2.5 and 0, what area formula could I use? Good. So the formula for a trapezoid says 1/2 times your width. In this case, these are my parallel lines, so that's my base 1 and my base 2. Your width, or your height, is the one that connects the 2 parallel sides. So my height is 2, so 1/2 times 2, and then the 2 bases, the 2 parallel sides, are what get added together in the parentheses. So the top one right here is 1, plus the bottom one was 2.5. So now the 1/2 times 2 cancel, so then it becomes 1, so I get 3.5. Okay, so now this one that wants me to find the integral from 0 to -4, I could add my -1.5 with my 3.5. So then I would get 2. That would be a positive 2. But this said 0 to -4. I want it from -4 to 0, which means I have to switch the sign. -2 is correct. So now if I wanted to start sketching f of x, capital F of x, I now have the ordered pair -4, -2. So that gives me an ordered pair that I could then graph. Okay, so now when I find f of -3, I'm going to change this now to a -3. So my trapezoid is still going to be that area of 3.5, but now I need this little smaller bit of the triangle. So that little smaller part of the triangle now has a width, or a base, of 1/2. So the half times the base, which is a half, times the height, but the height is still 2. So a half times 2 is 1 times by the other half, and that's a half. But I'm going to call it negative a half because it's underneath the x-axis. So now I'm going to take that negative a half, add it to the 3.5 area of the trapezoid. So negative half plus 3.5 is 3. But that would be 0 to negative 3. So negative 3 to 0 would be the opposite. So it's negative 3. Now when I find the integral from plugging in negative 2 for the x, I'll find the area under the curve from negative 2 to 0. So now I don't want the entire trapezoid. I'm going to shave off that little triangle part of it. So I will have to recalculate out that area. So I'll have a half. The height is still 2. The top base is 1. The bottom base is now 2. The half times 2 is 1. 1 plus 2 is 3. So this part of the trapezoid is 3. So when I go from 0 to negative 2, from negative 2 to 0, it's 3. So 0 to negative 2 would be negative 3. Didn't I have negative 3? I guess negative 3 is used twice. Okay, now when I do negative 1, at negative 1, I just have a triangle there. So the formula for area of a triangle is a half times the base, which is 1, times the height, which is 2, which that will all equal 1. So 0 to negative 1 is the opposite of negative 1 to 0. So negative 1 to 0 is 1, which means mine is going to be the opposite of that, which is negative 1. At 0 is nice because I plug in 0 for the x. If I have 0 to 0, that was a rule. If the limits were the same, it's 0. Yep. Okay. Let me erase some of this. Okay, so now I want to do the integral from 0 to 2. So now 2 is going to be my upper limit right here. So from 0 to 2, what's that shape right here? Quarter of a circle. Good. Okay, good. Pi r squared for the circle divided by 4. And my r is 2. So 2 squared is 4. 4 divided by 4 is 1. So it's just pi. Yep.
And the next time was 4 divided by 2 instead.
Yes. Yep. Okay, so now when I do the integral from 0 to 2, that answer is just pi. And I like that because it's above the x-axis, so I don't have to worry about any negatives. Okay, now when I plug in 0 to 4, this part's going to be another pi. Yes, so 0 to 4 will be 2 pi. And then when I go to 0 to 6, yeah. So then I'll have a half times the base, which is 2, times the height, which is 2. It's 2, yep, and then negative. Correct, 2 pi minus 2. Okay, now the answers, like the other ones, that's easy to do, where it says find f prime, f capital prime of x, which equals f of x. That one, since this graph up here was the graph of f of x, all it's basically doing is just looking at the graph they gave you, the original graph, and just stating the y values. So where it wants negative 4, x at negative 4, I would just look over here, negative 4, that graph was at 0. At negative 3, that graph was at negative 2. At negative 2, the graph was at positive 2. At negative 1, it was at positive 2. 0 was 0. 2 was up at positive 2. 4 was at 0. And 6 was at negative 2. So that part was easy. We just had to deal with the integral part where we had to find all the areas. That was hard. Okay, so it says on what subinterval from negative 4 to 6 is f increasing or decreasing? Justify your answer. Okay, how can you tell when f, capital F, increases or decreases? When you talk about above the x-axis and below the x-axis, that's if you know its derivative. So when the derivative is positive, it's increasing. When the derivative is negative, it's decreasing. So it increases when f prime is greater than 0, decreases when f prime is less than 0. So can we now look and determine where it's increasing and decreasing?
Yes.
Okay, where's it increasing from? So increases from our -2 all the way over to 4. And where is it decreasing? Okay, so this isn't quite right. So we need, when you look at this graph. So this graph that they gave us, f, that's the same as f prime. So when we want increasing or decreasing, you want to know where f prime is 0 or undefined. So where are the spots where f prime is 0? Okay, 0 is one spot. Where else? Okay, 4. Where? Okay, -4 and -2.5. So now f prime should be increasing where, between those values that we just identified, where the graph is positive, above the x-axis. So it's above the x-axis at from -2.5 to 0, and then it's also increasing from 0 to the 4. And then it's decreasing where the f prime is negative or below the x-axis. So it's below the x-axis from -4 to -2.5. And it's decreasing from, 4 to 6. So looking at the graph, identify where the derivative is 0. Now it says justify your answer, so then you would need to write out, like you couldn't just put that answer there, you'd have to put an explanation. So your explanation could be f prime, capital F prime is greater than 0, and then state those intervals. And then f prime, capital F prime is less than 0, and then state your intervals. So it's by letting them know what you're looking at. Or you could say, yeah. So the next one says find the absolute minimum and maximum. When it says absolute max or mins, remember you first had to find your critical number, so that's where f prime equals 0, which we just barely identified on the previous problem. But yes, so you have to check your critical numbers and your endpoints into the original function to find which one gave us the absolute largest and the absolute smallest it could be. Okay, so, and luckily we already filled out this nice table, so we already have most of the things we need for f, because we want to find the absolute largest and smallest in f. So my table, basically, my critical numbers were at, okay, so my endpoints go from -4 to 6, so you have to make sure you check -4 and 6. And then you also have to check all of your critical numbers, which were also -2.5, 0, and 4. Now I already have the answer for f on most of those because we figured that out when we did the first line of the chart. So f at -4, from the chart, that tells me that one was -2. At 6, it tells me that was 2 pi minus 2. I don't know -2.5, but I do know 0. 0 was 0, and 4 was 2 pi. So I do need to figure out -2.5. So to figure out what it is at -2.5, I'm going to come back up to the graph. And remember to find f of -2.5. I do the integral from 0 to 2.5, -2.5. So I'm finding the area from here to here. And we had already previously figured that out. I erased it. What was that original? What was it? 3.5? Now, since that's that would be the answer from negative 2.5 to 0. Yeah, backwards, so it's negative. So it's negative 3.5. Okay, so now if I want the absolute minimum, I want the one that has the very smallest answer, and the smallest y value answer was the negative 3.5. So I now know values of x on the interval, so I now know I have an absolute minimum of when x is negative 2.5, my absolute minimum is negative 3.5. And then for my absolute max, you find the largest y value, which would be the 2 pi, because 2 pi minus 2 at 6 is going to be less than that because you had to minus the 2 off. So at 4 comma 2 pi, so when the x is 4, you get your absolute maximum of 2 pi. Okay, the next one, on what subinterval from negative 4 to 6 is f concave up or concave down? How do we determine concavity? Good. So second derivative, now instead of f, capital F, so that means I need the second derivative of capital F. So coming back up to here, I know this graph, if you look right here, I know that graph f of x is the same as f prime, capital F prime of x. So I need the second derivative. So if I'm going to look at this graph to answer things, what do I need to look at on this graph to answer questions about the second derivative? Good, slope is correct. So now, looking at slopes, I want concave up. So you get concave up where the second derivative is positive. In this case, where the second derivative is positive slope. You get concave down when the second derivative is negative, which would be when the first derivative slope is negative. So positive slopes look like a curve from, what's that, negative 3 to negative 2. Okay, so concave up, so negative 3 to negative 2. Union, where else did we have? 0 to 2, okay. And that was it, okay. So then concave down when we have our negative slopes. So from negative 4 to negative 3. Negative 1 to 0. 2 to 4. Actually, do I need to break from 2 to 4? I could actually just say from 2 all the way to 6, because that's all just a negative slope. Okay, now it asks, what are points of inflection? How do we find points of inflection? Okay, so concavity changes from positive, or from concave up to down. A real point on the graph, and I know all these points are going to be possibilities because the first derivative did work. Okay, and then, so if I'm looking at the first derivative, what do I need to look at on its graph to find out where the concavity would change? And when would the slope change? When do slopes change from positives to negatives? Not on this graph, because this is f prime. We want to now talk about the slopes of the graph that we see in front of us. So when does it slope? When is the slope changing from positive to negative on this graph here? Yeah. Okay, so negative 3. 1, 2, 3. Negative 3 works. 0 works, and you said 2. 2 works. Okay. And or where it's undefined. So where's my undefined spots? Good, sharp points. But I wouldn't do all of the sharp points because say at like negative 2, it went from a positive slope to like a slope of 0. So it like flattened out, so that's not going to have concavity there because it has to go from a positive to negative or negative to positive slope. But I do have a sharp point at 4. Okay, so my possibilities for points of inflection are, let's see, negative 3. Points of inflection aren't an interval. They're individual points, specific spots. So on this one, you wouldn't do an interval. Okay, so those are, now those are just the x values. Okay, it says what are the points of inflection. So to actually know what those are, you'd state them as an ordered pair. But we already have this lovely little table up here that tells us the f values. So I now know at -3, I have a f value of 3. So then we'd have -3, -3, and then at 0, it tells me it's 0. Points of inflection. Points of inflection. I'm doing it into f because you want the point on the capital F graph. Okay, and then at 2, it tells me it's pi. And then at 4, it tells me it's 2 pi. Okay, now it wants me to graph f. So what I would do is I would just start by graphing all the individual points we know, like -4, -2. And then I would graph -3, -3. Thank you. -3. What's the next? 0, 0, okay. Oh, 2 comma pi, and pi is about 3.14, so up there. And 2 pi is about 6 point something, so we're up there. And what's, so 4 point something? Okay, so 6 comma 4 point something, about there. Okay, now I don't want to just start connecting these. I need to try to give it the correct concavity, concave up or concave down. So I now know that I should be concave up between -3 and -2, and it looks like, so if that has to be concave up between -3 and -2, then I kind of want to like dip down a little bit, okay? And then I need to be concave up between 0 and 2, so I know that that needs to kind of be, you know, kind of something like that-ish. It could be. Let me just get all the concavities in first. Okay, now I know I'm concave down between -4 and -3, so kind of just connect those, something concave downish. And between, yeah, -1 and 0, so maybe something like that. And then between 2 and 6, something like that. And then between -2 and -1, a straight line, yeah. Yep. Okay, so I'll just connect these straight, something like that. Okay, now, does that match with my absolute max and absolute min? So it says I have an absolute minimum at -2.5, comma -3.5. Yep, and I do right there. Absolute maximum at 4, comma 2 pi, and that's matching there. And then if my points of inflection were working, so all of this, my points of inflection ran into my concavity thing. So these right here were my points of inflection. So at -3, -3, that does look like it changed from concave down to concave up. At 0, 0, it looked like it did change from concave down to concave up. At 2, comma pi, that does look like it went from up to down. And then at 4, comma 2 pi, that was already concave down.
Oh, but that one was just an undefined answer, right?
Okay, so that one doesn't look like it would have ended up being a point of. So at 4, it was a sharp point, but it didn't change from a negative slope to positive slope or positive slope to negative slope. So I actually need to erase that one, as that one didn't end up being a point of inflection because the slope didn't change. So I'm going to erase, oops, I just erased part of the other one. So that one was not part of a point of inflection. The concavity has to change. The slope would have had to change. Okay, but the other ones all worked.
So